Well, my talk is about geodesign and what that can have to do with our curricula. Since the late 1970s, GIS has been used for landscape planning applications, first in universities and public authorities, later in professional practice of landscape architecture offices. CAD training courses in landscape architecture programs started in the early 90s. The slide shows examples from the early time when CAD drawings were printed on pen plotters, thus consisting of nothing than lines instead of nowadays usual inkjet coloring. The first textbook covering the complete field of graphic IT applications in landscape architecture, it was written in German, was published in 1992 by Andreas Muha from Vienna. Within 10 years, CAD applications in landscape architecture offices got widespread. In the meantime, architectural CAD software has developed more and more towards object orientation, offering tools, for example, to create walls, doors or windows. Landscape architects, however, when designing, for example, a driveway with the CAD software, are still used to draw a parallel line labeled as driveway, instead of using a parametric tool that starts asking you how you want the desired object to be created, including dimension, material, structure and all other information needed for the tendering procedure. So, from my point of view, still a long way to really intelligent CAD systems optimized for the needs of landscape architecture professionals. Jack Dangermond was one of the main initiators of a discussion on geodesign when inviting in 2010 an illustrious group of experts in the field of planning, science and IT to the headquarters in Redlands for the first Geodesign Summit. Michael Flaxman, in his talk, defined geodesign as a method which tightly couples the creation of design proposals with impact simulations informed by geographic contexts. Essentially, this brings together design, supported by CAD, and analysis, supported by GIS. In his recent textbook on geodesign, Karl Steinitz postulated geodesign as an interplay of four groups of actors, covering all scales, as there are design professions, geographic sciences, IT, and the people of the place. I understand the discussion as a vision for an IT support of a geodesign process going in the direction of an integrated tool including analysis functionality as well as design functionality. In other words, GIS, CAD and digital visualization functionality in one integrated tool. Many of the current curricula of landscape architecture programs are not well prepared for such a scenario. I see examples of more design-oriented curricula, digitally focusing on CAD, and on the other hand, examples of more landscape planning-oriented curricula focusing on GIS. The integrative aspect is often missing. For a master-level curriculum, Steinitz formulated an interdisciplinary and collaborative approach that is not rooted in one single department, but rather is supported by all respective resources of a university campus. It should consist of courses about all models covering the Steinitz framework in combination with applied design studios focusing different scales. In my understanding, this concept includes use of all relevant IT tools according to the state of the art. For an integrated approach already on bachelor level, I like to give you an example taken from my university in order to prepare students for the challenges of the geodesign approach. It starts with introductory lectures and exercises in the very first semester. Following in the second semester, there is a GIS and CAD lab in combination with a studio module. The task is to develop an ecologically sensitive design for a gravel pit, which shall be used after finishing the excavation as a recreational area in harmony with nature. The task includes technical planning and calculation of the excavation volumes, as well as the recultivation design with biotope development aspects. Starting point of a student's work is an inventory taking of biotope and land use structures of the project area supported by GIS techniques. Reflecting the analyzed situation, the students have to develop a concept for a gravel excavation, including a calculation of the excavation volumes. The next step of the studio task is to develop a design for the future use of the area, as mentioned before, finally also by applying skills gained during a CAD course running in parallel. By the end of the semester, the students have developed GIS and CAD skills and are able to apply these competences within the task of a landscape-oriented design studio. Nowadays, the technical part of the work is driven by separated software solutions called GIS and CAD. The future vision is the integration of these tools in a geodesign solution which supports students' work from landscape analysis to designing future landscapes without technological gaps. In the meantime, we can at least develop our curricula towards a more integrative use of the existing IT tools. Our profession should define needs in this regard in order to get not to get what the software industry is willing to offer us, but to get a product that really fits to our needs. And so far, I guess we are looking forward to another interesting decade of development. Thank you.
Thank you.